All right. Good morning, good afternoon, and good evening from Helsinki, and welcome to the Pulse of Networks webinar series, episode 17. My name is Claus, and I'm the CEO of Creanord. And with me here today, I have Miika Mattila, Director of Sales Engineering.
Hello, everyone.
Today's topic is a very interesting one, and we have many participants registered for this event. We are talking today about ensuring optimal network performance via advanced service activation and throughput testing methodologies. But before we start, I want to advertise that all of our previous episodes are available on our website as well. So if you are interested to look at some earlier topics, check under News and Insights, on-demand webinar, and you will find the previous episodes there as well. All right, let's get started. Okay, so what are the drivers for service activation testing and throughput testing? The standards in the field have existed for many years, and we have supported them in our system equally for many years. But from our point of view, there has particularly been a huge rise in interest in these methodologies during the last 2 years or so. Personally, I think this is particularly related to a switch in focus on user experience. Before, the main focus for networks has really been on the speed. But today's optical and 5G networks are already very fast, and speeds are sufficient for most users. So now the focus has switched to the user's experience of the network and to being proactive, making sure your site rollouts or modifications in the network are really done properly before going live. We see two main categories when it comes to drivers. Most of our customers are greenfield cases. They have not used service activation testing, at least not in a systematic way, and are looking to deploy a system that can offer automated testing capabilities. Some are looking just for the basic performance troubleshooting capabilities that these standards initially targeted. But now, really, the main use case that we see are proactively testing business services and verifying sites before you go live, and perhaps even providing the customer with a certificate that the service has been tested and is working fine before it is handed over to the customer. Business service verification is definitely one of the main drivers, but we are also increasingly seeing mobile operators verifying mobile site rollouts or modifications to make sure that everything is correctly configured in the network. One very interesting use case is also the regulatory use cases. So also with a switch towards the user experience, regulators are increasingly requiring the operators to produce all sorts of verification of the network performance in order to ensure that the customers are getting what they pay for. And finally, we see another category, replacement projects. So some of the early adopters of these techniques are using solutions that are outdated and end of life for the products, which force them to look for new and more advanced solutions. And they're also looking for replacing costly and time-consuming manual end-to-end RFC 2544 throughput tests with more modern solutions that offer techniques to centralize and automate the process. Okay, so let's compare these different test types that are available in this category. So first of all, we had the RFC 2544. The very standard one defined a long time ago for Ethernet services, widely known and used, but as a standard, it starts to be outdated. And the focus for this test was really on basic network performance, throughput, as the main KPI, although you can also get frame loss rates, latency, back-to-back frames for burst testing. But throughput is really the main KPI that you are looking for. In terms of interoperability, this is a nice one in terms of it just requires a simple MAC swap reflector on the devices. And on many of the devices, high-speed reflection is supported. So you can test it towards many devices in the network. Next one is Y1564, really the main test nowadays for service acceptance testing, defining the ITU-T, and in our experience used both for layer 2 and layer 3 performance testing. As this is more service oriented, so also the KPIs are more service oriented, packet losses, frame losses, delays, and delay variations. And you also can test multiple flows at once, so you can actually test that both the real-time services and best effort and other perhaps guaranteed service classes are working together in a simultaneous test. So in terms of interoperability, same thing as for the RFC 2544 when it comes to layer 2 testing. It's fairly well supported on the devices. However, on the layer 3, it's typically the devices do not support high-speed UDP echo that is required for reflecting the packets back. But in Miika's section, where we can show some nice developments that has been done in that field to tackle that problem. Then we have iPerf3, really done as a network performance testing tool, but also nowadays increasingly used also for user experience testing cases. Key metrics: throughput, latency, packet loss to retransmits. In terms of interoperability, it does need iPerf3 servers, but this software has been out there for a long time, and many of the operators are already deployed iPerf3 servers in their infrastructure. So if you are looking for an automated solution where you can have a centralized probe doing iPerf3 tests, you could just utilize those deployed iPerf3 servers as reflectors or as the targets for your tests. And typically this is focused on the TCP performance, but you can also do UDP tests with the iPerf3. Then RFC 6349 is more of a niche test. It's really for optimizing TCP throughput. So KPIs, of course, throughput, latency, retransmitted bytes. And here you really need to have probes in both ends to perform the tests. So it's really targeted at optimizing TCP performance for different amounts of flows. Let's compare RFC 2544 and Y1564 a bit more in detail. So 2544 mostly on layer 2, although you can do it on layer 3 as well, but we see mostly layer 2 testing, network performance oriented, whereas Y1564 is more service oriented and works on both layer 2 and layer 3. We see both use cases. And since Y1564 is more service oriented, you can do multi-stream testing. You can really verify the actual traffic flows that you have for a particular service. You can verify SLAs with it and so forth, whereas 2544 really is looking at the performance of a single stream, so it's not really related to SLAs. And as we discussed it before, the key metrics are also more service oriented for 1564, whereas 2544 is really throughput oriented and network performance oriented. So in terms of also network complexity, Y1564 is better suited for more complex scenarios, multi-service networks, as it can test multiple flows on both layers 2 and 3. Whereas the 2544 originally was really specified for device testing, but has afterwards been deployed for network performance testing. But it's more suitable for simpler network scenarios. Right, so let's look at the few use cases. So what can you use these service activation tests for? Well, number one is really the traditional way of using this test and RFC 2544. So you have a layer 2 network, you can have a probe at the central site, and then you are testing it towards the office location or other location where you have a router or switch with the layer 2 test reflector, max swap, reflecting the packets back. And there's some examples there on the types of reports that you get, really throughput oriented. Look at the throughput at different frame sizes and look at the performance then for these different frame sizes. And then you also, of course, make sure that you don't have any packet losses at any of the frame sizes. That's basically what you're doing in this use case. Now, use case 2. Same thing with Y1564, but now it's more service-oriented. Architecture is the same. You have the probe at the central site. In this case, as said, we are seeing it increasingly used for also verifying mobile site performance. So you may run the test on layer 2 or layer 3 towards a cell site gateway, or you may do it in a business service scenario towards an office location. But now the reports are more service oriented. You will see the KPIs per flow for real-time services, best effort, and other guaranteed services. And these tests have been run simultaneously, so you see how these streams affect each other, and you can verify it against the defined SLAs, and it will tell you whether the test met the SLI criteria or not. And further on, you can do for each flow configuration verification reports, which is very useful. For instance, in a business service scenario, you can hand it over as a birth certificate, show that your performance is okay for each of the flows individually, and then you can further add this performance verification report, which shows the aggregate flows as well. Now, a couple of newer use cases, not so usual use cases. First of all, we are seeing these techniques used increasingly in regulatory reporting. I said the regulatory use cases, because of the user experience, many different types of regulatory cases where you want the operator is required to report on performance. And as part of that, also using service acceptance testing. In this particular use case, I'm listing, you have a wider use case, actually a broadband test, which includes both these service acceptance test techniques and throughput tests, but also includes other measurements like DNS testing, web download testing, potential video testing, etc., for different types of reports from the user's perspective. And Miika actually has another regulatory use case, which is slightly different, which he will describe later as well. Last but not the least, very interesting and the latest use case that we have added to the portfolio, it is this mobile performance verification over the radio interface. And in this use case, as said, many operators have deployed iPerf3 servers, and they are used to using iPerf3. And in this particular case, you might have scenarios where you have your own personnel working in the field, working with a performance issue in the mobile network, or you might have a third party that's working for you in that mobile network doing troubleshooting. And then with this iPerf3 capability, you can use your own mobile phone to run an iPerf3 test towards our probe located centrally in the network. And this probe will then receive the test. It will take the test results and forward them to the pulse score system. So you have all the reports stored centrally, and you can analyze it centrally and automate it. So that's a very, very nice use case for automating troubleshooting over the radio interface. these are the four use cases we wanted to list. There are many more. There's many ways to use these techniques, but now let's look at some more advanced topics. So I hand over to Miika.
Yes, thank you, Claus. Let's next have a look at some common advanced customer requirements what comes to throughput metering testing and test types, considering them as an own independent use case set from the other main use cases like continuous active testing, like TVAM testing. To start with, the typical RFIs or RFPs do not detail so much about them, as mostly focus is still more on TVAMs and the like, or some user experience and social media capabilities. And then perhaps there are some generic requirements stated about throughput metering tests, like need to support also such and such standards, but that's pretty much the depth of it or lack of it rather. However, once having had deeper discussions with many of our customers, we have been able to extract some common, more advanced requirements that are of value or make a difference for them. Most of our customers have added throughput metering as a second or third use case, and in other words, did not necessarily get them via a RFP, and that has offered us a very good possibility to explore in depth what really could make a system to stand out and to best fit to their needs, apart from just fulfilling a standard A, B, or C. So overall, in addition to accuracy, biggest asks are sizing and scalability. Test probe physical size should not be more than 1 U, because rack space costs money, especially if your data center is outsourced. And operators, of course, vary in size and needs, but even for most demanding deployments, it seems enough if a couple of dozen probes can be supported in one management system, and if each probe can have 2 physical ports doing measurements at the same time, and this way they can also connect via redundant site routers A and B. Apart from test ports, also parallel test instances per port are many times asked, because there can be dozens of field people, engineers deploying sites in a given region, and several independent tests is therefore an obvious need, so that no one has to wait for a token to test their completed site or the site they are currently troubleshooting. For RFC 6349, scalability requirement of real TCP sessions can be anything between 1 to 1 million, depending on what you're after. Like if you need to test your network throughput end to end, or are more focused to find optimal max bandwidth, say for your office firewall device, for so and so many TCP sessions envisioned. APIs, we find, are more and more requested to increasing automation, and most commonly requested is RESTconf API, and of course it is beneficial if it supports all of the test types you envision to use. About why 1564 specifically, there are many smaller features that seem to be important depending on the use case. Many customers require scheduling, which is basic, but for regulatory purposes, recurring scheduling or a good API support is key. Automatic dispatch or upload of reports is also nice to have, but definitely a requirement in regulatory use cases. Both layer 2 and layer 3 test flavors are needed by most customers, but not all. And as far as interface speeds, 1G, especially copper, is phasing out or even not available anymore in newer sites, so things are going towards optical 10G. 100G is of course emerging topic already, but we see it will be mainstream in throughput metering only next year. No single flow at 10G allowed means that in some access parts of network, it is not allowed to run a 10G test stream in a flow of all similar packets, because they would then all take some single component link and push out other traffic there. So what is needed is a feature whereby packets can be hashed to different component links. We have seen the same requirement coming even from some very large service providers, and there just needs to be a feature in a good system to overcome this. End-to-end testing is a really handy feature to have also. End-to-end pre-testing, I mean. It means that in the beginning of test, a small stream of packets is sent even before actual test to check and report to user if end-to-end connection is okay. This is especially useful in case of layer 2 testing, which can be otherwise challenging to pre-check. Also, it is beneficial in layer 3 testing, as after it and when actual test starts, all ARC tables are already fresh, and there is no risk of losing some test packets to lack of it in the very beginning of the test. Going to advanced testing scenarios, it has been a dilemma for years how to get accurate and scalable test reflection capability to all the managed customer sites for customer line service activation testing and troubleshooting. Only a very few customer-side router models support proper Y1564 reflection for layer 2 and layer 3. For layer 2, some routers do support reflection of packets very well with their layer 2 line loop, but many times the proportion of layer 2 customer subscriptions is just less than 10% of complete customer base. So what to do in case of all layer 3 customer subscriptions and sites? Smart SFPs have been the obvious first proposition for a long time, but many times they are deemed too expensive for any wider deployment. Next ideas have been to look into routers' other features, but services like UDP small servers and also IPSLA UDP Echo typically run as limited software processes and can scale only up to a few megabits per second and with rather bad quality. Within the last couple of years, a solution to overcome has been discovered. It is based on use of inherent feature readily present on typical business CPEs. Here, we will not reveal what or how it works, but we can state that we have successfully tested a few vendors and many device models for compatibility. As concrete examples, however, for instance, a Cisco ISR 4321 has up to 50 megabits reflecting capability, and Cisco ASR 100X has up to 10 gigabits reflecting capability with performance license onboarded, and they both perform very well, we found. This discovery has opened many new use cases or advanced methodologies in area of throughput metering, as you will see also in some of the following slides. Here in this first actual testing methodology presented, the service provider is actually already taking benefit of the CPE reflecting capability presented in the earlier slide. This methodology is about the local regulator, or this use case is about local regulator dictated need that service providers operating in this market need to prove that customers will get their service up to their subscribed CIR bandwidth, and testing of it is called link saturation testing. Testing for each customer needs to be done each night, and results must be reported daily. In this very market, typical CIR values for small business customers are mostly 40 megabits per second, and typical service providers have perhaps some hundreds of customers, and as each customer site needs to be tested for 15 minutes, it will be enough to cover testing of all of them during each night, even with just a couple of smaller probes having a 1 gigabit per second test port each, and where 20 customer links are tested in parallel within one test instance before moving to next 20, and so on. For such use case, solution does not need to be super scalable, but it has to have great reliability, as penalties of failing to report of customer links being tested successfully each night are high. Repeat scheduling of tests or good API is also important to have to save time, as well as reports auto-dispatch feature so that human repeated works and errors can be minimized. As we next look at bring-up testing of new sites in mobile backhaul and small business customer segments at larger service providers, different needs arise to run the acceptance tests towards their sites. In other words, testing for each site needs to be executed as a fully independent test instance from any other, and the completed sites are all verified independently by field team peers as soon as any of the sites becomes ready. It is also to note that different sites and services may also be tested with different SLA parameters and at different times and for different durations, Hence, they all need to be individual test runs. All of this requires great parallel scalability from the testing system. There are probes in many regions, and same probe may be used to connect to different segments or even domains of network. So at least 2 physical 10G ports are needed per probe. And since there could be dozens of field people working on their sites in the field, great scalability and flexibility to start the test by probe at any time is needed without much waiting. The typical requirement we see about this is that up to half a dozen parallel test instances need to be supported per probe test port. For UI then, the key requirements in such use cases come from testing in masses. In other words, it has to be possible to create templates and also easily be able to search historic reports so that any testing and repeat testing and comparisons can be fast and easy to do. Test itself has to be with good follow-up features, and if all is not going as expected, it has to be indicated at an early stage so that the test can be stopped and troubleshooting quickly started. However, once all has gone well, in the end, a nicely formatted birth certificate report needs to be created automatically, which can then be handed over to peers or customers, most typically in PDF format. Our last methodology or use case example today is mostly focused on business VPN service delivery. And the dilemma about end-to-end testing of such business services, meaning testing from customer site A to customer site B and between any other customer sites according to subscribed business VPN service and topology. So traditionally, especially trained engineers needed to be sent to different sites with specialized ROC tester equipment to do an end-to-end test between them. And these endpoints could locate within a country or even in different countries, as there could be any number of them. Organizing people to be in these different locations suitably around the world in some synchronized way for such end-to-end testing to happen, well, it is of course a tedious exercise to manage, time-consuming and very costly. And question had become, could the same not be done in any better way? And yes, a better way is possible today. During the past 2 years or so, we have seen as an emerging new method the centralized and segmented testing, where an end-to-end connection is tested in 2 parts, each individually, and then the KPI results are simply merged and stitched together. The tests for the 2 segments are initiated from a probe somewhere along the path in the middle, and essentially in the end you will then get the similar KPI values reported as an end-to-end test would give you. So only you just test the connection in 2 parts and then merge the results for the same outcome. But as you can now do this in 2 independent tests and using a centralized system and fully remotely without ever needing to leave even your office chair, it of course brings many benefits. This could even be considered a game changer, actually. In other words, results will automatically be in a centralized system, and there is no longer a need to fly people around the world in synchronized schedules, but any test segments can be tested individually at any times and then merged for end-to-end combinations when all needed test reports are available. All of this gives great flexibility and generates huge time and cost savings. Basically, any VPN service type and topology can be tested using this methodology as long as there are proper test probes and report generation tool, and the customer CPEs themselves can be used as test reflectors. Use case examples could include, for instance, testing a new VLL service or adding new site to an already existing VPLS or VPRN. The methodology is completely business VPN service type or topology agnostic and can be used both in initial service bring-up phase or when adding new sites or troubleshooting. API support for the same is of course beneficial to have also, and today we're seeing customers even starting to automate such testing fully, which will bring even more time and money savings. And back to you, Claus.
All right. So let's conclude. So this service activation testing nowadays is starting to become an essential part of the service assurance toolsets that the operators are using. And we see it, as said, we have started to see it 2 years ago with the Y1564. We are seeing a lot of also replacement projects more recently. And we see more and more use cases as well as they have really great applicability to many different use cases. And generally, you could say Y1564 being the kind of de facto modern standard for these tests, but at the same time, of course, RFC 2544 still are very useful in multiple use cases, as well as IPERF 3 and RFC 6349 have their very specific use cases where they excel and are the best protocols of choice or methods of choice. Automation, proactiveness, user experience, troubleshooting, site verification, birth certificates are some of the key reasons that why you really want to use service activation tests and these throughput tests methodologies. And of course, the Pulse Shore system supports all of these different tests. We have both physical, virtual probes supporting these tests with a central pulse score reporting system, which can provide you the reports or automate it through APIs, as Miika was describing, for fully automated solutions. And in addition to that, you can also augment it with all sorts of active monitoring and user experience monitoring features as well. Okay, so that's all we have time for today. If you have any questions, you see our emails at the bottom. And if you are looking, you want to do a proof of concept, have a session to talk more, or if you're interested to see this new methodology of using a standard CPE as a high-speed reflector, we are happy to discuss any of these topics and other topics that you may think of. Please contact us and we'll set up a session and talk more. So that's all we have time for today. So thanks everybody.
Thanks for your time.
Bye-bye.